Microsoft actually has come with this offering of Azure machine learning, and of course they've made it priced very, very, very. I'm just going to go to the price listing over here, and it's a great starter place, and that's why I show people who want to get started with it. This is a great place to get started. The pricing wise, it's free. For quite a lot of experimentation can be done. 10 GB worth of max storage space and 100 modules. I'm going to solve a problem with 5-6 modules. That's all is enough. So it's quite a lot of exposure which these people have provided. Even the paid point of it is not that expensive. It's at $10 per person per month. That's a very, very reasonable price for a sophisticated kind of software or platform kind of a thing. The whole point they're trying to push is they're trying to battle that war of cloud and try to compete with the big giant, who is AWS. Exactly. So that's what their intent is, and everybody is going to that battle challenge. So what I'm going to do is I'm going to use that, and they have something called as Machine Learning Studio. So I have signed into my account. It's a free account. There is something called as Azure subscription. You don't even need a subscription to get into this. So they're trying to make it as less barrier as possible. Now, what I have done is I have logged in already. So I'm into my account already and logged in. And I'm going to take a simple example and build on to what I said before. But there are a few more pieces in the whole process, which of course we didn't cover in that initial parts, but take an example and follow through the whole process. Now, when I come to this this place, and we'll go systematically and try to take one problem. So if you come to the machine learning studio in Microsoft, and there is something called as a experiment. This is a terminology which Microsoft has put together. So we are going to create an experiment. This experiment is about income prediction. It's going to predict the income of a person, right? And what it's trying to do is, like, this one is trying to predict if the person is above 50K or below 50K. That's all it's trying to predict. Now, it's a very useful problem to solve. I think it's a very useful marketing problem. Let me ask you a very funny and humorous question. How many of you get private jet flyers at your home? Not yet, right? That's a good answer. So not yet. So why? Why do we don't get private jet flyers? Why do we keep getting Home Depot or Chipotle or Subway kind of brochure, right? Why? Why is that? It's common sense question. I think. Yeah. So somebody has done profiling. Somebody has done some kind of algorithm and understood the profile, the demographic, and figured out, no, this is suitable for Home Depot, or this one, or this, so and so forth, not for this kind of perspective, because they want to save their marketing dollars. They want to just keep on sending to everybody on the planet, right? It's not worth spending that kind of energy. So let's say we take the same model. Instead of 50K, maybe it is 5 million, which you have to have the income, and then probably you'll get that flyer, right? So that should be a goal right there. But this model may be for something else, right? So you're kind of doing. So each of these patterns can be built on use cases and several things ahead of it. So I'm going to take that and move forward. So this one is trying to predict whether the person has going to be 50K plus or less, right? So we start with this. What Azure has done is like made this panel complete drag and drop kind of option. So to start with this, we bring the data, and this data is around 32,000 rows, a little more than that. And it actually already has a column called income. And what does that tell you? What kind of learning is this? Supervised or unsupervised? Supervised. We have the answers already predicted for certain amount of data, which is already predicted that. In this case, we took a sample set of data. You can bring your data, all that is possible. I'm just taking a sample data. Then, I did not teach you one other thing. Now I'm going to take the opportunity to teach that. In the machine learning world, what we take our data set and we break our data into two parts. There is a training data set and there is a test data set. We break that data into two parts. So let's say we have 100 records. Some percentage will break into both of these. So let's say 70-30%. 70% is training and 3% is test data. Why are we doing that? What we want to do is, like, first of all, we want to build a model on certain amount of data, and then we want to check it before we go into production and try to predict random people's or new set of data. I want to check it, right? That 1, 2, 3, 4, whatever you were doing in the beginning, you also did that. You checked with the fourth value. Oh, 64, I'm good. you kind of doing the check, right? So we always break the data into two parts. The percentage is not fixed. You don't have to do 70-30. You don't have to do 80-20. There is no rule, right? So a lot of people ask, like, how much should I break? It doesn't matter what you break. The volume of data is not important. The kind of data is very important. So if I am, for example, building a model which is kind of identifying cat images and dog images, let's say I'm doing that. So my data should be, which I'm learning, should have both, right? I should give the learning model some cat images, some dog images. If I only give lots and lots of dog images, my model is not going to work, right? When you give somebody a dog images, the model, and then you say, show suddenly a cat image, it will say, it's a dog. Because that's what I've only learned. Like, it's like going to a kid and teaching them science and science and science and suddenly asking them math test. Like, I didn't learn, you didn't taught me that. So that model has been not taught that thing. It's very simple. It's not rocket science. It's all the same concepts. Simply apply that. So the important thing is not about how much data, kind of data. And also I told you before, it's not important what algorithm, the data is more important. And now I'm telling you not only the volume of the data, it's the kind of the data, the mix of the data, right? If I'm going to test somebody on math and science, I better teach them math and science, right? If I'm going to test a model on cat and dog images, I show all the cat and dog images to the model. It's not going to magically create something, right? So that's the important point. So don't worry about one thing. Many of the systems have default 70-30, so just like a general rule, not like a fixed thing. Sometimes we do 50-50 and 80-20, depending on what is going on. Data is more important. And we can go back and forth as well. I might try 70-30. I don't like it, go back and I'll do 80-20, something. And that may give me a better result because I got more data or less data, any of that. So we'll split that data. We need to split that data. So what we are going to do is go in this panel over here, and there is a box called split data. We bring that box, connect it there, and here it says 0.7, which means 70%. And then there is some random seed in front of it, how the randomization should happen. That's what it's going to do it. So as simple as that, dragging and doing in this kind of a model. Other places you'll write a code for this. The next step, which everybody is very curious and excited about, is the algorithm. What algorithm do I use? What we did in the first part, we picked an algorithm by using the cheat sheet. However, we came with that algorithm, we selected this algorithm. Most of the time, the data scientist is the one who will say, let's try this algorithm. So let's say he came up with the approach of 2-class boosted decision tree. That was the algorithm decision. Like we made a decision. This is the algorithm we are going to use it. So let's try it with this algorithm. Let's bring an experiment. So we're going to search for that name, 2-class boosted decision tree, and we drag that as well. We connect that panel, and then we call the train model. Using this model and this data set, 70% of the data, I'm going to train my model and build a model on top of it. And then what I'm going to do, I'm going to create a new column, not the existing one, a new column, income. We could have called it predicted income, but a new column with that, and that will help us do that. Now, I need to validate that model. So I'm going to go and score my model, how good my model is, this algorithm, this data set, how good is that? I'm going to apply that. And then we have a evaluate model kind of a thing. I'm going to score that, check if my answers are coming right, and then I'm going to evaluate overall my model. And finally, when I have this 4-6 modules put in this experiment, right, with very simple kind of steps, I think we can see like experiment built in. We're going to go and run it. And I'm going to run this with a simple click of a button. It's going to spin for a little while. It's going to go in the queued mode. And then it's going to go in the running, and it should not take much time. It's just 32,000 records. And it's going to go ahead and start doing that analysis and kind of say how good our model is, what our model is doing, everything. It should be out in a few seconds or a minute or so. But the point is you notice everything was drag and drop. I did not write a single line of code, right, in this kind of a system. So, and then this model can be taken out, exported out, and applied in other places, right? It's a great starting place. I'm not encouraging you on Azure only. Other places also not like that scary. It's like very easy. So once the model is run, we visualize the data, and this is the score label. So now the new labels and the score, the probability of how much we are saying in the results to this model kind of a thing, right? And then we see, and these are different ways to look at the model and how good the model or bad the model is. eventually you end up with this 4 different kind of things, which in this kind of a model, we come up with 4 different things, and there's something called true positive, true negative. When I say something is positive, I say this person is 50K above, and he is. So then I have reached a point called that answer I've given true positive. If I said somebody was 50K above, but it didn't happen, that is true negative, right? The true negative, false. So those 4 combination comes in. This 4 combination of values, either it can be true positive, true negative, false positive, false negative. It is so confusing that this thing is called as confusion matrix. The name itself is given as confusion matrix. Your goal in the confusion matrix on this diagonal, the true positive and the true negatives, that's what you're trying to increase. That's what you're going to think. If you have everything here and nothing over here in the false, that's nirvana, which never happens. Never happens in real life. That doesn't happen. So you have to find the right compromise which you are looking for. And then there is all these matrices which I'm not going to talk at this moment of time. But you see, slowly, steadily, you build a model, you try it, and you say, my false positive is so much. Now I'm going to go back and say, oh, this algorithm, no, I'm going to try a different algorithm. Oh, I'm going to get more data. I'm going to remove some data. Sometimes having more data is creating a problem, right? I have a field called favorite color, and that is messing everything, right? So it could happen, right? Sometimes data is reduced. So all those tweaks and things, we keep doing it, and we'll try to keep on improving our model. So that was a very simple demonstration, very short and compact, but condensed and goes through the whole step-by-step kind of a system. All of those systems, whether it is Azure, whether it's GCP, AWS, everybody's built a framework kind of these systems. In the Python base, we write some set of code, not so much code. You can do machine learning in less than 10 lines, less than 10 lines. So it's getting more and more commoditized that way, and good for people to get into